today's session. In today's seminar, we have the honor of having Professor Liqiang Huang from CHK to deliver an interdisciplinary talk about his exploration on using machine learning and AI technologies to expand and to extend psychological theories. Actually, Li Qiang used to be one of my professors when I was a student in CHK. As indicated by this picture, it was 18 years ago. I was a PhD student at CHK. Li Qiang already became assistant professor there. At the early stage of his career, he used the traditional and classical paradigms of hypothesis testing to have his to design his studies and develop his own theories and models. I still remember that uh, when it was in 2008, he already published in Science and the Psychological Review as first author. Then after so many years, I thought probably Li Qiang has already been very satisfied about his achievements. But then, to my surprise, very big surprise, he continued to explore novel ways of doing research, and many of his work, his projects have led to publications in those prestigious journals. I think it is not just about the publications; it's more about his approach of continuous learning and continuous exploration. So without any delay, now I will hand it over to Li Qiang, and let's welcome Li Qiang to deliver his talk today.
Thank you, Guan. So now I just share my screen. Is it working? Can you see it?
Yes, we can see it.
Oh, okay. Uh, okay. So thank you, Guan, for giving me the opportunity to speak in this wonderful meeting, in this wonderful situation, and I'm so glad that there are so many people here. I thought you would not be very interested, but there's so many people. So let me get started. Like this is technically the last slide of this presentation. Normally I just put it by the end, and but given this is an online talk, I imagine many of you may have to leave in the halfway, so I will just give you this information right now. Uh, Because in this talk, even if it will last for 1 hour, I can only present a small part of the story. The full story is too long. If you're interested, you can check out this paper, uh, which is on review of general psychology. It's not a typical paper. It's more like a thought and a story. And to help you understand, I also created uh, videos in English on YouTube and in Chinese in Bilibili. So just you can just find those if you're interested. Thank you. Okay, let's get started. So this paper. So uh, so unlike most research talk, this is more like a sharing of personal story. So all this begins when I start in graduate school as a PhD student. Because I was not trained in psychology, my understanding may not be very typical. And so imagine the way how I study would be to make it more like a physics. I understand that it's not as easy, but I think it's going this direction is the way to go. So my earlier perspective is a mature psychology would like physics and building a theory that is simultaneously precise, broad, and simple. That's like my goal of doing research. Okay, you will I will explain to you why those three terms are especially important: precise, broad, and simple. So this is like the earlier representative of my earlier approach, which is the Boolean map theory. And like so you may wonder what Boolean map is. So I can tell you that in just a few seconds. So basically we claim that where our conscious access, our conscious awareness is very limited. At any particular moment, you can only consciously see one thing at one moment. And our operational definition, for example, using color. But you can see many things, many locations. So basically, location is different because it's so fundamental to our vision. So in this particular example, please take a look and tell me if the left and right side, they are the same exact set of locations, meaning the same spatial pattern. I'm sure you can see that almost immediately, right? They are the same. And if I ask you, they are exactly the same set of colors, it will take you some time to verify that it is. It is, but it's not so obvious. It will have to verify red, red, blue, blue, purple, purple, black, black, and it will take some time before you can verify that. That is the basic claim of the theory, because this is today's talk is not about this theory, so that's all I want to tell you about it. Okay, so when I just started, and especially when I just finished those original theory, I was very optimistic. So basically, at that time, I saw no fundamental barrier between psychology and physics, and I was optimistic that the same scientific process would lead us to a grand unifying theory. I mean, this may be confusing. I'm not talking about a grand unifying theory of whole psychology. That's obviously impossible. I always knew that. I'm talking about a grand unifying theory of one topic, like attention or like visual awareness, things like that. But then it becomes obvious that it's impossible. So why it is impossible? So let me tell you the whole story. Basically, my career can be divided into a few stages. At the beginning, when I just started becoming a assistant professor, that's the picture. How when that picture was taken, when like Guan just show you. So my belief was that we need to battle weakness. So to do better research, we need to try to make things precise. My goal is to spend 5 years making the Boolean map theory more precise. And my belief was that all the problems in psychology and probably the same thing for the whole behavior and human and behavioral science, including management. It's like all the problem stems from not being precise enough. So I believe all those irregularity and ambiguity on the surface will disappear once we make everything very precise. That's what I believe. However, what happens is that after 5 years, I spent 5 years making the Boolean map theory very precise, and I did make progress in making it very precise. And the outcome is not what I wanted, because I found that increasing precision inevitably resulted in greater complexity. Whenever you try to come up with something that makes things very precise, you always found things become more complex because you always found there, okay, I didn't realize there is this factor. I didn't realize that there is this. And you end up finding tens or hundreds of things you need to consider once you become very precise. All these things become obvious once you are very precise. So that was a bad time in my life, and somehow like practically I have probably done 1,000 experiments. Maybe typically enough for 100 papers, but I didn't publish any single paper out of that because I don't know how. The things are too complex. I couldn't find any unifying theory or just a general perspective or anything. So that's basically very bad time. And so I spent a few years in like searching for the answers and like feeling overwhelmed and depressed. And my final realization after those like years is that my pursuit of simplicity itself was the problem. So I should not have pursued simplicity. And then this is more like more complete understanding. Like in physics, you can have precision, breadth, and simplicity all at the same time, like Newton's laws or Maxwell's equations. But in psychology, once you have precision and breadth, you can't have simplicity. You're doomed to deal with very complex situations. And my conclusion is that there is a PBS, impossible trinity, in psychology. And I do believe it applies to all the behavioral science, humanity, etc., social sciences, including management. So basically, you can have either narrow findings, experimental findings. They are inevitably fragmented if you try to be precise and simple at the same time. Theoretical concepts are normally vague, and they have to be vague if you want to be simple and broad at the same time. And if you try to be both precise and broad, you have to deal with complexity. And the best approach I think we need to take is something I call comprehensive exploration. I will explain to you today how that works. So basically, this is what I call the PBS impossible trinity. Basically means it is, by its nature, it's impossible to do perfect research in psychology, in whole social sciences. It's just impossible to do perfect research. You have to do, they have to be flawed or like not good on at least one of those things. Okay, you may wonder why. Is there a reason? Yes, the reason is quite simple. Basically, a psychological process or just a general mental process, which is underlying any of the social sciences, is like the elephant. I'm sure you all know the blind man and the elephant old story. So it is complex in nature. It is a complex entity composed of interconnected yet distinct parts that cannot be reduced to a single rule by its nature. So, like, if you try to look at all the different parts of the elephant precisely, then doomed, then it's, of course, complex. There's no way to just talk it away. You cannot just play some magic to make it go away. Okay, so I hope I've convinced you that, like, in psychology, in management, in whole social science, we can't achieve all three at the same time. And what can we do? What should we do? So basically, there are three possibilities. You can either do fragmented findings, focus on one very narrow situation, and you can argue the elephant is like a snake, or you can just look at the whole picture, but keep it broad, keep it like vague. Just use some terms like energy, resource, or optimization. Just something vague that can cover anything. Like in psychology, we have attention, memory. Those are common terms, but each of those can be explained in at least 10 ways, sometimes even more. So those are two ways, typical ways of doing research. And although this is just a value-based judgment, I argue that the most valuable research is actually describing the elephant or the elephant. To show the elephant is like an elephant, not arguing the elephant is a snake or arguing the elephant is a pillar, as many people do, or just simplify the elephant as a sphere. So, but this is a value-based judgment, and although um many people do not speak out, I do know that some of them do sincerely believe it's better to do fragmented research or to two-week research for some reasons. But I do believe that we should describe an elephant as an elephant, so which is scientifically valuable. Okay, if you agree with me, or at least open-minded to it's possible that we should describe an elephant as an elephant, then this is what I did next. So in the next 2 years or so, I tried to build a complex theory, and I soon found it's impossible because things cannot be integrated. It's not standardized enough. The outcome is that insights from individual studies provide impossible to integrate. So, and the lesson I learned is I should develop something more systematic, something that's well designed, try to standardize a lot of things in a broad range. So that's lead to the third phase, which is also my last phase before I switch to the comprehensive exploration approach, the new approach today. So the last, in those years, I did standardization. The goal is that standardized tasks and stimuli across an extensive range of conditions so that they can be compared meaningfully. Standardized means make the task as homogeneous, as uniform as possible across a lot of tasks, and also try to use standardized and comparable stimuli across a broad range. And motivated by this belief, as you can imagine, this is something very difficult, take a long time. And did try the number of things, but I will just talk about one line of study. I will tell you why. So in 2015, I did this. It's not a it's not nothing broad. It's just a very typical traditional experimental finding. Two stimuli types multiply three tasks. It's a typical 2 by 3 ANOVA. And then I extended it to 16 stimulus types multiply 8 tasks. And then finally expanded to 16 stimulus types multiply 26 tasks. And that's a lot of effort put into it. As you can see, it took 7 years for me to finish that. Although that particular study did get published pretty well in Psychology Review, but I still consider the whole attempt of the period a failure. Why? Because of three walls. First is the data size. I needed tens of thousands of data hours, but could only collect about 10% of that in the lab. And the verbal theories, they proved too weak to capture the necessary complexity. And experimental design, it became impossible to manage more than 5 factors at once. So concretely, I have tried 3 to 5 things in this period, but this line of study is the only thing that's successful enough to be published. All those others go to folders. And because for one of those reasons, I couldn't get anything clear. I couldn't publish those. So, however, everything I've told you, you think it's depressing. Okay, we can fail for this, for that, but the final, most painful realization is here. So when I first published that paper, I was actually quite excited. I thought I've finally addressed a very important question in the field to give a whole review, a whole picture, kind of like draw the first picture of the whole elephant, and the people should get excited. But then, to my surprise, I found so that's my imagination, like broader scope, greater scientific value. That's what I imagined. But it turns out in reality, the greater complexity, less appeal. Particularly, one friend and a colleague who really liked the earlier study, think it's elegant and very interesting. He told me that. And then after a few years, when I happily show him this study, he frowned and said, well, he didn't know how to make out what to think out of it. He didn't know what to make it out of it. And he didn't know how to understand it. Basically, he thinks it's too complex. He is not interested to read, and he didn't know how to interpret. Basically, he didn't like it. And that's not the single person. Basically, I normally send my paper, those what I like, to something like 10 to 20 colleagues who I think uh, that's relevant. And for this paper, just a rough number, I probably have sent it to 15 people, and maybe with the exception of one or two, all of them write back and say they like it, and apparently they have read it. It's a psychological science paper, just very brief anyway. So you may think, okay, people just always nice, so like they will always say that. But wait until this. This I also send this to even more people, something like 30 people or near that. And most of them write back and say, wow, impressive. I look forward to read it. I will let you know after I read it. And no one, not a single colleague, write back later. So I suppose none of them actually finish reading it. It's apparently a very long paper, like more than 20,000 words, and with a lot of different details, different issues. So you get the point. The point is the ideal is that we value deep theories, we value deep understanding. The truth is that cognitive bias consistently reward simplicity. So enough is enough. That's the end of a 20-year era. And then I decided I have to do something different. So then I moved to the comprehensive exploration, as I will tell you today. But before I tell you the exact method, let me explain to you a little bit about curse of complexity. So I told you that complexity was a problem from my own experience, but there are psychological research on that. Basically, in academia, complexity creates difficulty on two levels. First, when things are complex, the work is difficult to do. And when you work on something narrow or vague but simple, the work is much easier to do. Like my science paper. So that which is narrow, which then work is easier to do. And also my earlier psychological review paper, which is vague, then work is easier to do relatively. And the precise and broad study also earns little credit because it's difficult to publish it already because people don't want to read complex papers. And even if you happen to be lucky to be able to publish, even if you publish well, no one is going to follow it because it takes too much time. So give you very little credit afterward. No one is going to read it, no one is going to notice it. So to summarize, what is the lesson? Take-home message. I mean, this is one take-home message you can consider from this talk, is that if you try to do precise and broad studies, basically high quality, deep studies, you will suffer because of complexity. On the other hand, if you stick with simple but narrow findings or simple but vague theories, people will like you because it's simple. They will be favored for simplicity. So the key to academic success is to do a lot of low quality studies. And the easiest way to kill yourself, like in academia, is to do high quality, complex studies. Okay, so at this point, you probably think this guy is very cynic. He thinks the whole community is bad people and etc. Actually, I do not. I don't think it's good people versus bad people issue. I think it's human nature. To be clear, I have done a lot of those things to other people, like when I review paper, and I even if I suspect there's something important, but because it's too complex, I try for one day, I still couldn't understand what it is and I have to give up. And I have to tell the editor I couldn't understand it. And you can imagine what happens to the paper to get rejected. So, and there are also published papers. I tried to read it, but after I tried for 3 hours, I still couldn't understand it. I gave up. So it's the same thing, not just good people versus bad people. It's human nature for everyone, including myself, including every one of you. No one like complex but deep studies. Everyone likes simple but narrow or weak studies. Not because they are weak or narrow, but because they're simple. So I'm not saying like people don't appreciate the value of deep studies, but that the complex induced burden is too much. And the way to do it is to reduce this. After reduce the burden, then suppose like I don't have to suffer by doing complex research or reading complex research, then I will be happy to do it. I do want deep studies, high quality studies, but how to do that? So that's a critical point of today's talk. So how to do that? I think we can learn from like AI. So basically, for many years, we have been learning from physics, which pursues simple and elegant physical laws. In psychology, it's like that. We have those working memory theory, attention theory, which is quite simple, but they fail to capture the complex truth. That's the way how it works. But I think should not be the way how it works. On our hand, we should learn from AI. We should build complex theories. We should try to manage complexity, but how? Okay, let's see how AI navigates the Trinity. Basically, AI achieve breadth through large-scale dataset, achieve precision through quantitative modeling. To be sure, AI cannot achieve simplicity, but they achieve ease. Even if they have to deal with complexity, they don't have to deal with it in a difficult way because they have standardized benchmarking, which can reduce complexity-induced burden. So it's like it's in psychology, you have to carry something that's really heavy. So to avoid that, every one of us almost stick with simple studies that's either vague or like narrow. In AI, the thing is still heavy, but they don't have to carry it. They have a car or something else to carry it. They have a tool to carry it. So which is standardized benchmarking. So that they can happily deal with that complex situation. So how to reduce the complexity-induced burden specifically? Basically, benchmarking cuts the burden of complexity with one powerful move. It replaces endless debate with a single objective metric. In AI, a complex model's value is instantly clear from its benchmark score. For example, if it's a face recognition, if recognition accuracy is 99%, it's obviously better than another model that's with accuracy of only 50%. You don't even have to say that. But in psychology, I don't think it's necessarily the case. So you can have very complex study that explains the like data, the truth really well, but it wouldn't sell. People would prefer another simple story that didn't even fit actual data just fit with that one very narrow experiment. But it's a nice and elegant story. People will go for that. So we need something objective. In psychology, we have no such score. Imagine two series of object recognition, each supported by various findings. We're left arguing which finding is more interesting or which interpretation is more persuasive, which is highly subjective. And we end up making the judgment on how simple some things are. The simpler, the better. Or even worse, on whether, like I'm sure you know in the international community, for example, whether the researcher speaks perfect English, whether researcher is tall and good looking, whether researcher has a good appearance, etc., which is even worse than simplicity. So that's bad enough. But to make it even worse is that in AI, they can easily scale up. Like in the last 10 years, the AI models on many things have scaled up for 100 times or even more, 1,000 times. But in psychology, if you have a study, or in management, if you have a study with like 1,000 separate experiments or 1,000 separate surveys, you imagine that's the best study in the world. But the truth is that nobody is going to even read it. So you end up getting nothing. We can't scale up. That's a problem. Okay. So after presenting this story to many colleagues, and most psychology researchers embrace or at least do not object to elements like large-scale experimentation, quantitative modeling, and benchmark testing. Like many of them say, well, large-scale experiments are a lot of trouble, but yeah, if you want to do it, that's fine. That's better. Quantitative modeling is difficult to do, but if you want to do it, oh, that's fine with me. And benchmark testing, yeah, difficult, but if you want to do it, okay, that's fine. So at least in principle, all of them agree with it. However, there is this one thing. Learning from AI comes with an inevitable cost. We must abandon the traditional theory-driven experimental design in favor of an AI-inspired, stimulus-driven approach. This shift meets with considerable concern. So although almost no one openly objects large-scale experiment, etc., but quite some people, like at least 10% of my colleagues and just the peer researchers, strongly and clearly argue against me. They say, no, traditional theory-driven study is the gold standard. Your like AI-inspired stimulus-driven approach is not theoretically rigorous. I think they're wrong, and I will argue for that. Let me explain why this transition is necessary. Okay, why we need to transition from theory-driven to data-guided. Basically, precision and broad studies are inevitably complex and involve many factors. Traditional methods in psychology start with theory, requiring us to define all variables clearly from the beginning. Because you have to define the theory and generate hypotheses to even before you start an experiment. Because it's too complex, you can't do that. So we quietly, silently, just sneakily start with something very simple, a simple theory, very narrow one. And then that's why we avoid all those complex possibilities. So that's why you cannot do precise and broad but complex studies in the traditional framework. On the other hand, AI methodology starts with data, eliminating the need to define all variables clearly from the beginning. So it works really well. So let me tell you a personal attempt and its failure. So in the old times when I still believe in theoretical theory-driven study, but I want to do it in a more broad way, I went to the literature and made a list of all the known factors on working memory, trunking, interaction between items, etc. After months of struggling, I had to surrender. You could say maybe I just wasn't skilled enough. But look at our entire literature, you will find a three-factor design. Sometimes more common is just a two-factor design or just one factor. Three-factor, there are some, but very is already quite uncommon. But you will never find a 10-factor design. To clarify, I'm not talking about in some of those like principal factor analysis in which you get 10 factors. I'm talking about experimental design. You design a 10-way or 15-way experimental design. Have you ever seen any study like that? I never see one in psychology. I bet there will be no such study in management or any of the like social sciences. So that's clearly supports my point. It's impossible to do complex research that can reflect the truth with a traditional approach. So the solution is stimulus-driven design. So the old way, predefine factors, design stimuli, and collect data. The new way, you define a stimulus space, sample randomly, and later let data review factors. You define the stimulus space, all possible four color combinations on the color wheel. In one study, we do that. That's one. So when I tried this in theory-driven way, I couldn't do that. But then I can with that stimulus-driven design. I achieve a possible four color combinations. So when we do random sampling from this space, we draw 10,000 color combinations from that defined like a stimulus defined space. So to be clear, this is inspired by the practicing AI. ImageNet did not predefine cat. It used natural image of cats to capture that. So I think many of you probably know what ImageNet is. Imagine ImageNet did not start with a large set of objects, pictures. Instead, they try to first define all the factors matters for object recognition. Can this succeed? I bet not. That's why theory-driven study is not suitable for large-scale studies. So after we made the shift from theory-driven to data-guided, still we care about theory. I want to be clear. It's not like we no longer care about theory, but just the theory is now the destination of the study, not the beginning of the study. We start with stimulus-driven design. We end up getting theory. We don't start with theory. We end up with theory. So this is basically the four steps of this comprehensive exploration approach. Unfortunately, I don't have time to explain it in details or give you concrete examples. If you care, watch the Bilibili video or YouTube video if you don't understand Chinese. I don't know if anyone like that here. Anyway, like basically we started with the design, which is stimulus-driven design, just first tell you. And then we do a large-scale experiment, data collection. And then we do analysis with exploratory iterative model building, just to go through the loop. And finally, we produce a quantitative, well-specified model, but it's also information processing model, which is like completely interpretable. In AI, researchers build a benchmark dataset in iteratively develop models until they achieve something remarkable. ANIX-led, for example. In psychology, we can do the same, and hopefully something great will emerge soon. We call this a comprehensive exploration approach or the CE approach. Okay. So I also want to tell a little bit about how the third step works. I already tell you how the first step works. I suppose data collection and output is more self-evident. So I will tell you a little bit about how the data-guided theory building. Basically, we first have a best model based on previous understanding, which is probably not the best anymore. And then we read the literature and we find the patterns in the data. We develop a new model. We compare. The winner becomes the new best model. And we repeat this again and again for 1,000 times or at least hundreds of times until we find something precise and broad, but a little bit of complex. that can explain the data well. Okay, in the last 10 minutes or so, I will tell you advantage of the CE approach. You may think, okay, that's an interesting and unique approach, but what's the advantage of it? You have told me a lot of disadvantage, which is complexity, but what's the advantage? So the major advantage is that it can possibly merge, simultaneously get explanation and prediction. You may be confused. What are they? So explanation is like in traditional psychology or social science in general, we try to achieve something that we can understand. The quest for transparent, mechanistic understanding of the mind. It's like a blueprint, but unfortunately, it's like typically we have explanation, but not prediction. Prediction, on the other hand, is like we make perfect prediction, but we can't explain it. It's more like an oracle that can predict things, but it would not tell you why to make that prediction. Let me give you one concrete example. For face recognition, although I'm sure you all know there are now video cameras everywhere with face recognition software. Basically, we rely on deep neural networks for those purposes. They are black box-like neural network. They are very accurate, stunningly accurate, but you don't know how it works. There's no story or explanation behind the mechanisms, so interpretability is low. On the other hand, you have those perfectly explainable psychology theories, such as you first make anchors on each part and you calculate the difference by a Bayesian model, etc., etc. The advantage of those is that it is perfectly explain. You can perfectly explain it. It's completely explainable. But the unfortunate part is simply do not fit the truth very well. So you never see it being applied on the video camera in the street because the accuracy would be too low. Okay. You think, okay, that's impossible. I mean, that's obvious. You have to either have one or the other. Isn't that always the case? I argue, at least potentially, you don't have to choose. So in this one particular study, if you're interested, also when you like watch my like Bilibili or YouTube videos, I will explain that in detail. Is that in this one particular study on working memory, we do find a model that's only 57 parameters, fully explainable, but then it beats a neural network in terms of fitting. It fits the data even better than neural network. Of course, it's a little bit more complex than traditional psychology model with only 4 parameters, but it's still reasonably simple so that it's still explainable. So that's the beauty of this result. That's primary advantage of the CE approach. So you may think, okay, that's just one study. I don't even care about this study. So let me give you one more inspiring example. Suppose, I'm sure you're all using GPT or DeepSeek these days. If one day we can build a DeepSeek that's with maybe only 1,000 parameters, fully explainable, would you be excited that can perform almost as well as DeepSeek today? So perfectly applicable, precise, accurate, but still understandable. Wouldn't be you excited? Of course, I couldn't achieve that, but I think this is the direction we should go. I mean, in my lifetime, I will try to go on that direction and try to maybe I will go uh, all the way, try something like face recognition. That's possible, but language processing is just beyond my capacity. But anyway, I think if enough of us try that, we will eventually get there. That's a long-term inspiration. Another primary advantage of this approach is that I believe it can potentially lead to a paradigm shift in psychology. So what paradigm shift? Uh, in AI, we have this magic cycle that transforms AI. Basically, we have a shared goal, which is a public benchmark data set, and the innovation engine is like global researchers try to beat each other on like matching that on like building models on a benchmark. And then we have fair judge, which is standardized indexes like recognition accuracy for face recognition. And also there's something else for the large language model. But anyway, we have to need something objective. Then the progress loop is iterative improvement. And finally, we get better and better. So in short, this cycle tells a powerful story, a shared goal, and a fair judge create a competition that encourages everyone to focus on genuine innovation, driving continuous measurable progress, not on the appearance or surface, but on the substance. Basically, I believe by introducing this logic into psychological research, the CE method could, if widely adopted, inspire leap in psychology comparable to the AI revolution. Of course, that's just the inspiration, but I think it's possible. So to put it another way, we will transform from a science of stories to a science of solutions. Basically, current psychology, or just management, or the whole social sciences, we compete on tell a story to persuade others. Basically, we focus on appearance and spin, not on substance, because that's all that matters, a story. However, if we can have this benchmarking, we can build a better system. We can have a ruler, build a quantitative better model. If you build a better model, you don't have to dress for success. You don't have to speak perfect English for success. Your success will be self-evident. So that's a better system to drive like genuine progress, real scientific research, not just stories, which I think is much better situation than it is today. Okay, so we're back to this again. I think we're okay on timing, about 15 minutes. And so now if you have questions, please
Mm.
ask me. I will try to answer your questions. And again, please consider reading this paper and like watching those videos because we are, as you can see, we are just starting. And many people, or I see most people, okay, I should say many people are interested, but very few people are actually picking it up because its complexity. It's a very unusual paradigm. So I try to promote this to as many people as possible. So please consider watching this video or read this paper, and if you like it or at least like the spirit, tell this to others. So spread the word. Thank you. That's all I want to say.
Okay, thank you very much, Liqiang. Actually, we have 1.5 hours. If you still have time, we actually have 1.5 hours,
Oh
not
yeah,
just
sure, sure. Like
yeah.
if you have that many questions, yeah.
So yeah, so I think the timing is perfect because it allows more interactions and Q&As. So from the for the audience, if you have any questions, you can either put in your questions into the chat box. Li Chang can pick it up and answer the questions one by one. You can also unmute yourself and directly ask Li Chang.
Any questions?
Um, Actually, I had expected you to introduce a bit about your paper uh, published in Nature Communications. It is like a concrete example or comprehensive exploration approach, right? Do you mind,
Yes.
do you mind
Like
introducing a bit?
I imagine we wouldn't have enough time,
Mm,
so I didn't include that. But maybe I can show another PowerPoint a little bit
yeah. And
on that.
we just received this question from the audience. Actually, yeah. I think the audience are generally interested on how stimulus experiments are actually designed. So
Okay,
it
okay.
might be helpful, yeah, to give a concrete example. And maybe you can
I
also
will.
introduce a bit about your experience on how to publishing papers on later research journals.
Uh, okay, just you need to give me 1 second. I need to get it from another my desktop.
Okay, okay, take your time and
Yeah, yeah, yeah.
please continue to raise your questions.
Okay, I can share the screen for the other PowerPoint now.
Yes, yes.
Uh, Let me see. Where do I find the? Oh, okay, okay, okay. Share. So this is the information I put in another similar. So please tell me if anything is unclear. So basically, I start with a large scale experiment that has more than 30,000 hours of data and 40 million responses. But it's a still strictly controlled experiment. So basically, we measure the working memory for all these situations. And we have a theory to explain it, which is the 57 parameter theory I told you. It's not a black box neural network that just give you an answer. It's an information processing model. Its entire reason for existing is to simulate how the uh, visual memory works. So let me tell you, okay. So how do we test a model like this? We give input 10,000 such color patterns, and we do the output, like the model generate output, and when then we match that output. The animation is not showing up correctly for some reason, but anyway, they are supposed to. Okay, so basically here, okay, so I kind of show, for some reason the animation is not working, but basically the colored shade, the data, and then the white lines are the model, and feed those model to those data for 10,000 color patterns, and then train the model, not just train the model, but just optimize the model, both mathematically and also conceptually to make it fit better. So I will tell you a little bit about how the model works. So basically, it try to capture different type of memory. We could have biased memory. Let's biased towards those classical color category like red or blue. We also have pure guesses, like you've already forgot it, just to make a pure guess. Or we have swap errors. You remember the color, but in a wrong location. Or we have unbiased memory, you actually remember the memory. And for each of those, like we use a normal distribution to capture it. So this process happens in three key phases. We first do something like they affect each other before the category was built, and they calculate the weights and the mixed responses. I suppose you don't care about the details, but I will tell you a little bit just so you understand the level of complexity it has. So it is a little more complex than typical psychology or social science models, but it's still understandable. So this is a full model. You see it's moving. So the phase one, phase two, phase three, not too complex. Uh, Altogether about 12 like different levels. And then we already beat neural network, remember that. So with just this amount of complexity. And then I also want to tell you it's not a black box. We actually understand. For example, and there is this previous finding. I also confirm in my findings that there is this situation like when two colors are very close to each other, they attract each other. But then when they are a little bit of similar but not too similar, they push each other away in memory. To to capture this, we use this Mexico hat-like function, which is well-designed, well-defined function in modeling to capture this kind of phenomenon. Also, we found that a quality trade-off, this concept, like when you remember a lot, you don't remember them so well, or you can focus on one, remember it really well. That mental mechanism is implemented by using a unified ratio to link the quality and the quantity. So when one is higher, the other is lower. So that is kind of, so every step is understandable. It can be explained. It's not black box, just a little bit of complex, but it can be explained. We also ensure conceptual algorithm alignment. For the model's trunking mechanism directly affects how often swap error happens. This makes sense psychologically when items are trunked together. You're less likely to mix them up. So this actually makes sense psychologically, and then we use one parameter to capture that. So all these findings are put together in one framework. And then like magic. So you would think it's impossible to beat neural network, but you have to capture enough, not so many, just maybe 20 or 30 such fragmented findings in one framework. You are as good as a neural network already. So that's a critical point. Okay. So that's how we get like a breadth, precision. That's how we manage simplicity because we use standardized benchmarking. So I know you're particularly interested in stimulus-driven design. Let me move to that part. So how do we do the stimulus-driven design? Okay, I already told you why. I already told you why it failed. So my goal was ambitious 10-way factorial design, but it didn't work. And then I turned to stimulus-driven design. So our ultimate goal is to build better theories. But the very worst way to do that is to start by rigidly defining every detail of that theory in advance. That path is guaranteed to fail. The counterintuitive solution is to do the opposite, to step back, let go of the control, and let the data itself review the path forward. So actually, it's not difficult, it's actually easy. Let me tell you this concrete example. Okay, so this again, I showed you like you traditionally select factors and then you design. Now we define a broad stimulus space, sample randomly, and let the data self-review. So in that case study, so this is a critical point, how we do it. It's actually quite simple. We first define our stimulus space as all possible 4-color combination on a color wheel. So basically, we have 4 items in each trial, and each of them could randomly vary on the whole color wheel. And then we just randomly generate 10,000 color combination. Just like that. It's the end of the story. That's the design is finished. So each of them is randomly chosen from a color color wheel. Let me show you. So each of those, it's kind of small because I want to show you that there's a lot. Each color is randomly generated. Another is randomly generated. So it's like a 4-color combination of randomly generated colors. That's it. Simple like that. And then it captures all the classical findings as expected. So not only were all classical effects present, but they emerged with a clarity that theory-driven approaches often misses. Ultimately, we capture those factors simultaneously without needing to define a single one in advance. So theory-driven design fails beyond three factors, it hits a wall. Our case study using a stimulus-driven approach captures those factors simultaneously. No difficulty at all. I mean, you have to do some work in modeling, but in the design stage, it only takes 5 minutes. Like four colors, each randomly generated with MATLAB. You can do that for you in 1 second. That's it. This proves the problem was not a comprehensive study itself. The problem was trying to achieve it with a theory-driven design. Okay, so like so if you guys sticking around, maybe I tell you a little bit about also how to do the iterative modeling. That's another essential part. Let me skip this part quickly. So here I'm just saying like many people in psychology and in social science think what I'm doing is strange, but I think it's not strange at all. It is just going back to the classical scientific discovery to respect the truth. When we don't know something, we take a lot of data and then observe the data. That's how physics started. That's like I don't think it's right that now we would be so arrogant that we should not look at the data. We always start with what we believe. So that's I think it's a wrong attitude. Okay, so the another part of this is how to do the exploration, do the like iterative modeling. So basically, you might have heard from your experimental design research method professor, or you maybe you're teaching it yourself, is that you should always predefine hypotheses. I teach you that course for many years. It's not wrong, but it's not just cannot be applied to large scale studies. Basically, when you do that, it's like a predefined hypothesis. It's like a fixed route you can go. But in like our open-ended exploration, we're just like a rich data set to explore. Our goal is to answer this very simple question: what's going on there without any particular preset goal. We just try to understand what happens, which I think is honest and scientifically better attitude. And how it works, the data-guided serial building loop, I told you this already. Okay, so this is in the quick. In our case study, we repeated about 1,000 times over 8 months. But now I'm getting better. Like so if I do this again, maybe just in 4 months, but still longer than typical hypothesis testing. But I think it's worth it. It's crucial to understand while this process is data guided, it remains rigorously theory oriented. Every iteration explicitly tests theoretical hypotheses through formal model comparison. So we are data guided, we are stimulus driven, but we are not less theory oriented. We are just strictly theoretical as traditional studies. Just we don't start with theory, but in the end, we have better theory than traditional study. So okay, give you an example like in this one finding, this is that I found that items in working memory interact with each other. I assume like it will interact after like color categorization, but it turns out I was wrong. And then data is much better, fit much better if I swap the order of those processing. So I accept what the data suggested. So that's hypothesis testing. But the hypothesis testing, not like based on your pre-generated hypothesis, but the hypothesis you generate throughout the data analysis. So at this point, some of you will probably think that's terrible. Like you keep generating hypotheses, keep testing it. Isn't that the standard like a bad practice of like post hoc analysis. You can see it's post hoc, but I think it's not problematic for the reason. So first, we to ensure rigor, we use a CAD like a matrix. A huge concern is that we could just keep adding parameters to get a slightly better fit. A traditional statistic like a p-value would be too easy. To prevent this, I use a much stricter metric developed called CAD, complexity adjusted Conversely. It's an effect size measurement. So basically that means we only keep something if it's actually important. So this is a very strict standard, and as I will tell you, it actually matters. To be clear, this CAD serves as different purpose than traditional model comparison to as AIC, BIC, and cross-validation. On one hand, this is a measure whether the effect is real. On the other hand, this CAD is done to measure whether effect is important, so it's not affected by data scale. CAD is much stricter. So this whole process might sound similar to a problematic practice known as harking, hypothesis testing after the results are known. You might have heard, you might think, okay, that's why people do pre-registration and everything. So it's bad practice, but they are different. Problematic harking is hypothesis after this is about obscuring the process, hiding that, presenting of exploratory findings as if they were confirmatory all along. But we are open in being exploratory. Our approach is about total transparency. We are explicit that this is an exploratory, discovery-driven process. The honesty is built in. We never hide that. We always make it clear we are exploring. You may think, okay, you're exploring, but then how about the false positive? As you may have heard, if you run 10,000, okay, 10,000 too many. I didn't actually do that. If you run 1,000 like analysis after data is collected, if you try, then the p-value would be inflated by 1,000 times, right? You have heard of that. I agree, but that doesn't matter. What about a false positive? Testing 1,000 models would normally set off every alarm bell. If there's absolutely nothing, you would get 50 hypotheses get confirmed by a p-value of 0.05. However, our standard CAD is so strict, the combination of massive dataset and CAD keeps the actual false positive risk very, very low. One is like 10, that so little, minus 87, 10 of that in our case study. So for us in practice, this was simply not a concern. So even if you multiply that by 10,000, a million, so what? Still extremely small. Some of you might be thinking, why use this iterative modeling process? Why not just test every single possible model? The answer is simple, it's impossible. The space of possible models is too many. If we test that, we would not be able to finish by the end of universe. So that is why we have to use our judgment to explore, not to exhaust testing all the models. Then a related question is why not just exhaustively test a small, well-defined set of models? That's not an artificial question. That's actually a question a reviewer gave it to me. Here is the answer. An incomplete exploration of a large space almost always yields a better solution than an exhaustive test of a small one. Our model ended up outperforming a previous landmark model like this in the field, not because we are better modelers. Actually, I think they are much better and more experienced modelers than us. However, we're willing to go beyond this small factor space. That's why we can get better fitting. Our advantage wasn't better skill, it was a broader approach. We weren't limited to a predefined set of factors. Okay, now it's interesting part. I bet some of you are watching this and still feel a little uneasy about this process. Something about this feel less certain, feel strange, wrong. And you know what? That feeling is incredibly common. It's probably a big reason theory-driven design remains so popular. We want something certain. We want an exhaustive test of a small space. But that feeling is actually cognitive bias, what we call the paradox of choice. Guan will know it better than me. It's a social psychology phenomenon. We have a strong preference for small, manageable set of options that we can fully exhaust. So basically, I'm saying if you prefer that, if someone prefers that, that's because it's better for science. That's because the cognitive system has a flaw. That's because we are biased towards simpler options. So, like, basically, it's not scientifically justified. It's like preferring the certainty of a small familiar room to the vast unknown outside. Your feeling of unease, it's not the outside world, it's your fear of it. So the problem is you, is not the outside world. Okay, so just to summarize this part, because of this exploratory nature, we have to embrace a progressive mindset. CE models aren't presented the final perfect truth. They represent the best understanding we have right now. If someone builds a better model tomorrow, I mean, generally in psychology, if you come up with a model and someone come up with a better model next month, that means you have failed. But in our system, I don't think that should be interpreted that way. That isn't a failure of the CE approach. It's its greatest success. So the more wrong someone prove my CE model is, the more successful I am, because that means this is a path that can lead to truth. This is how science should work, iterative, cumulative, and always open to improvement. This is how science always should be, standing on the shoulders of giants, and you should also be willing to be the giant to allow others to stand on your shoulder. So to conclude, exploratory model building isn't a messy concession. It's a powerful engine. It's a rigorous data-guided process we use to build theories from the bottom up. It allows us to ask thousands of questions, to navigate impossible complexity, and put psychological science on a path of genuine cumulative progress. So that's, again, all the things I want to add. Hopefully that answer all your questions on the additional questions on the method. So let me
Okay, thank you
see.
very much, Liqiang. I think after you introduce the example and also the thoughts on the discipline should move forward in terms of building better theories using more advanced approaches, I think most of us would have a clearer idea on in terms of understanding it. Then a more concrete question would be the question following the first one. Is this paradigm appropriate for the management field? I think it's a common question asked by one of the audience for all of us. So, based on your understanding in the field of management, can you give us some kind of tips on how to effectively use it to advance management research?
Well, I don't know the management field well enough to come up with maybe not very good. So I can just, with my limited understanding, for example, uh, something I do know about. Okay, so the different like management style, like how to manage like employee, like strict management or just more hand-free. Is that a important topic in the area?
Yes, then I think you remind me of the leadership research. Maybe
Okay,
can
but
we use leadership research, different leadership styles as an example.
okay, and also okay, I will give you a more uh maybe interesting. I don't know if it's relevant because some days ago someone approached me saying he is from business school. I think it's closer. And he didn't actually follow up, but he did come up with some interesting idea. He said in business, there is this study on what kind of CV is the most effective. I think that maybe many of you also care about that if you're going to go to job market in the future. And according to him, like they have identified some factors that like about the CV that are known to matter and known to interact with each other, like two or three of them. I forgot what they are. But then he asked me the exact question, how to do that study in stimulus-driven design. I said it's straightforward. You don't come up with any factor. You end up trying to generate 10,000 virtual CVs and ask participants and to rate, okay, how likely, uh, how uh, how strong this candidate looks like, and then with all those virtual CVs, and then you use I mean, of course, we should keep it reasonably simple, and then we analyze all those factors. And also, you can do this for many things. I don't know if this belongs to management, but in the okay, maybe for more for like a social psychology or sociology, like even like when you read the profile of someone online, how likely are you going to trust this person? How likely are you going to trust his ability? For example, if you're going to find someone to fix your computer, would you choose a beautiful lady, well dressed, or would you choose someone that looks really nerdy? Or if you're going to present something, find someone to present a project, would you choose each of those? But then we can generate. We don't start with an factor. We generate. May if we can find a real profile, that's even better. I mean, but maybe there's a problem of the privacy and we don't have the right to use them. But anyway, we find some either real or virtual profiles, and then we ask people to rate, and then we do the deep analysis, find out, okay, that's beneath it. Okay, that factor is what's beneath it. So does that make sense?
Yeah, thank you very much. I think that's a very, very inspiring tip for many of us. But a follow-up question would be, it seems that the comprehensive exploration approach starts from defining the stimulus space, right? So
Uh, yes, defining
for management
stimulus space.
phenomenon, when management research topics, usually the stimulus space is quite complicated. So how can we make sure that we capture enough in the stimulus space?
Uh, well, it is complex, but probably it's not more complex than object recognition or those things, right? Those are real world image.
Hmm.
So, okay, the answer may be this. You may be encouraged that or discouraged. So, simple answer is that we cannot make sure it's perfect, cannot make sure it's sufficient. We can only based on intuitive judgment. Okay, just like when people try to collect a data set for image recognition, object recognition, they just try to get a lot of image online. You just get a lot of profile. It could very well be that it's not enough. Turns out that something is missing. But I imagine from a practical point of view, um, if you are much broader than all the existing approach, then that's already a good scientific academic progress. And practically, you can also already publish it well. And if you notice something is missing because you didn't realize it or because you didn't have enough resource, then you just uh, run a second stage of second phase of data collection and include that. That happens a lot in AI. And so you just add those later. So there's no magic bullet on make sure of that, just based on intuitive judgment. I will give you story. Like we tried a experiment on artistical styles. So we want to see, okay, what kind of now there are all kind of things that and my one of my students is interested in study what is defines a style. And then the way how we did it, we don't know where to find it. And then we end up just finding a lot of like known artists. And then we assume each artist is likely to have one style. And then we find 300 artists, well-known artists, and use each of those. For each, we use like 300 representative artwork or 50. I forgot the detail, but anyway, for each one of them, we use a set of representative work. And we did, the data hasn't been fully analyzed, but we did capture, we believe we have captured something interesting. But unfortunately, after we finished data collection, we noticed that there are actually like a public data space, like from Middle Journey, they have well-defined style database already. Like they, if you go there, you can find like you can define a style, and they are this. I mean, the most importantly, their style is much broader. They have all those modern like style. I know our the style we have tried to stick to the traditional artist, so it's kind of narrow in that sense. But doesn't matter. Like we can probably still publish it, like eventually. But just next time, if we want to study this again, we just add those into our set of stimuli. Yeah. So that's the
Okay.
question. That's the
Yeah.
answer. Thank you.
Yeah. Thank you very much. We still have a remaining question from Yuhua. I'm not sure whether you can share some of your insights about the question at the bottom. So in management research, especially empirical studies, so it related to the issue of how to theorize
Mm.
your paper. And
Scholars are typically encouraged to draw on no more than two theoretical perspectives to explain a single dependent variable. In reality, however, far more than two theories, and the associated variables are often relevant. Should we move beyond single or dual theoretical lenses and instead incorporate all plausible factors and apply data-driven techniques to? Okay, so my answer are several levels. First, if you ask me scientifically, whether this tradition is right or wrong, I will tell you clearly it's wrong. It's not wrong in the sense that it's always wrong, but it's wrong in the sense that in the case of large-scale studies, no longer uh, and it's no longer applied. If you're doing traditional small-scale study, it may be the actually better idea for statistical reason. I mean, if you're doing a small-scale study, you wouldn't have enough data to distinguish between many possibilities, so it's better to stick with two or just two hypotheses. But if you're doing large-scale study, then the whole story is different. So my answer is scientifically, the tradition is wrong, or it doesn't apply to if you want to do large scale study. If you are asking me practically, would we encounter difficulty with reviewers or readers? My answer is yes and no. My impression is that we tend to get extreme responses. Uh, like when I submit my paper, some are very enthusiastic. So I can tell that when I submit my Nature Communication paper, like one reviewer is very enthusiastic, and no reviewer has ever been so enthusiastic with like my any of my traditional old theory-driven paper. So my answer is that sometimes you will get strong supporters. Like you don't have to worry that there's no supporter as long as you make it clear what you're doing, and people do understand and appreciate, especially the younger generation. However, we also get extreme responses from the opposite. Like once I give a talk, someone stand up and saying this is the worst thing one can do, blah blah blah, like strongly against it. Think it's a shame, it's a violation of scientific principle. But I imagine I haven't met one such in reviewers, but there are some who actually stubborn. They're not implied, but they're stubborn and against it. That does happen. So, but my general, I have several general advice. If you want to do it first, try higher level journals. If you try those lower tier, of course, there's no point. And if you try like after you take so much trouble to do finish a grand study, you want to publish it well. I can tell you that for nature science and nature communication, nature human behavior, those they may not like your particular study, but they do appreciate this approach. They understand it. The editors, I mean, like they know the value of this, so you don't have to worry about the editors wouldn't understand. But again, the reviewers, some of them may not like it. So another practical, or maybe you can a little sneaky, is like when you write your paper, you package it in a way that's more like AI related, big data related. Don't package it as a like a typical traditional study. Because if you package the traditional study, it will be sent to a traditional reviewer. But if you pick it, if you package yourself as a more like AI for science or large data, big data attempt, it will be sent to those people. And I can tell that generally speaking, they like this. They like this approach. They may not understand the psychology part or management part very well, but they like it. And finally, if you ever do this, and you don't know who to suggest as reviewers, you can suggest me. Like I think I would be a valid reviewer for this, for the relevance of method. And you can email me. I can make a suggestion. I know a list of people who are who really like this approach, and I know there are at least 10 or 20 people who really like this general methodology, like researchers in method. So of course, nothing can be guaranteed, but you can still run into one. That happened to me, like once. That's stubborn and just simply didn't like it because against the traditional. But I think the chance is good. Not perfect. Nothing can be guaranteed, but but if you do all this carefully, with all this strategy, I would guess the chance of publishing a really good journal is 70% or even higher. Yeah, that's my guess.
Okay, thank you. Thank you very much for those very inspiring and encouraging words of trying something new and how to build dialogues with potential reviewers and editors and readers. Do we have any remaining questions? We still have 3 minutes. Anything you want to ask? Okay, if there are no remaining questions, can I ask everyone to thank Liqiang for this very inspiring and also very provoking talk. Thank you very much for your time. As Liqiang just mentioned, he also had uploaded a lot of videos to Bilibili and YouTube. So if you are really interested, you can look into those online workshops, online seminars. I personally watched many of them. I find them really, really. I think the first image impression is they are really shocking because some of those ideas you may not fully endorse them, but on the other hand, they are really, really intellectually stimulating. I hope that today's talk would be a starting point for us to think about something new, something that can dramatically change the paradigm or enrich the current paradigms of doing high quality research. Okay. If you have no further questions, I will end today's session. Thank you very much, Li Qiang.
Thank
See
you
you.
very much, everyone, for
Okay.
coming. Thank you.
Bye.